Welcome to this chapter on sectional views, an essential skill in technical drawing and design. By the end of this chapter, you will have a solid understanding of how sectional views enhance clarity and communication in technical drawings. First, we'll describe the purpose of sectional views, learning how they reveal hidden details by slicing through objects to expose the interior. Then we'll explore the different types of sectional views, from full and half sections to offset and broken out sections. You'll also become familiar with the symbols and the convention used in sectioning, including proper section lining techniques to ensure your drawings meet industry standards. We'll discuss which features should not be sectioned, such as ribs and spokes, and how to maintain efficiency by applying smart sectioning techniques. Finally, you'll put this knowledge into practice by preparing your own sectional drawings using advanced CAD techniques. Let's dive in and master the skills needed to create professional, precise sectional views. Technical drawings must show all parts of an object, including the insides and other parts not easily seen. Such details can be drawn with hidden lines, but this method works well only if the hidden part has a simple shape. If the shape is complicated, the hidden lines can be confused. See Figure 8.1a. In these cases, a special view called a section or a sectional view should be drawn. A sectional view shows an object as if part of it is cut away to expose its insides. To best understand sectional views, imagine that a wide blade knife has cut through the object. Call the path of this knife a cutting plane. Then imagine that everything in front of the cutting plane has been removed so that the cut surface and whatever is inside can be seen, as in Figure 8.1b. On a normal view, a section line called a cutting plane line shows where the cutting plane passes through the object. That's Figure 8.1c. On the sectional view, the cut surface is marked with thin, evenly spaced lines known as section lining or cross-hatching. The basic section lining pattern that uses thin, evenly spaced lines is used in most cases. It is a general-purpose symbol used for objects made of any material. It can be used especially when only one kind of material needs to be shown, such as on a drawing of a single part. Section lining symbols are provided by ASME to indicate specific materials for a sectioned object. Under this system, the general purpose symbol can also mean that an object is made of cast iron. These sectional symbols are most useful on a drawing that shows several objects made of different materials. However, do not depend on these symbols alone to describe the materials to be used. Specify the exact materials needed in a note or in a materials list. The cutting plane line represents the edge view of the cutting plane. ASME specifies two forms of cutting plane lines, as shown in Figure 8.4. The first form is more commonly used. The second shows up well on complicated drawings. At each end of the line, draw a short line with an arrow to show the direction for looking at the section. Draw the arrows at right angles to the line. Place bold letters at the corners as shown, if needed, to reference the section. A cutting plane line is not needed when it is clear that the section is taken along an object's main center line or at some other obvious place. See Figure 8.5 for an example of the symmetrical object in which the center line serves as a cutting plane line. If a drawing shows more than one piece in a section, place the section lines in different directions on each piece using common angles of 30 degrees, 40 degrees, and 60 degrees. Avoid using horizontal or vertical section lining. Remember, however, that any piece can show several cut surfaces. Make sure that all cut surfaces of any one piece have section lines that go in the same direction as shown in Figure 8.6. A full section is a sectional view that shows an object as if it were cut completely across from one end or side to the other. Such views are usually called sections. Such views, the vertical section, a full section taken from an object's vertical or front view, and the profile section, a full section taken from an object's profile view, are the two most common types of full sections. The cutting plane of a section is usually taken straight through the object. However, it can be offset or shifted to show a detail or avoid a part. See figure 8.10 for this type of section, known as an offset section. The cutting plane in this figure is offset to pass through the two bolt holes. If it were not, the bolt holes would not show in the sectional view. Show an offset section by drawing it in the cutting plane line in a normal view. A half section is one half of a full section. While a full section shows the object as if half had been cut away, a half section shows 1/4 cut away. Imagine that two cutting planes at right angles to each other slice through the object, as shown in figure 8.11a through figure 8.11c. Figure 8.11d shows the object's exterior, not in section. The half section shows one half of the front view in section. Half sections are useful when drawing a symmetrical object. Both the inside and outside can be shown in one view. Use a center line where the exterior and half sectional views meet because the object is not actually cut. In the top view, show the complete object because no part of it is actually removed. If the direction of viewing is needed, use only one arrow. See figure 8.11e. In the top view of figure 8.11e, the cutting plane line could have been left out because there is no doubt where the section is taken. A view with a broken out section shows an object as it would look if a portion of it were cut partly away by the cutting plane and then broken off to reveal a cut surfaces and the insides. See figure 8.12. This view shows some inside detail without drawing a full or half section. Note the broken out section is bound by a short break line drawn freehand with the same thickness as a visible line. Think of a cutting plane passing through part of an object, as shown in figure 8.13a. Now think of that cut surface as revolved 90 degrees, so that its shape can be seen clearly, as shown in figure 8.13b. The result is a revolved section, also called a rotated section. Use a revolved section when the part is long and thin and when its shape in cross-section is the same throughout, as in figure 8.14. In such cases, the view may be shortened, but the length of the part must be given by a dimension. This lets you draw a large part with a revolved section in a shorter space. When a sectional view is taken from a normal place on the view and moved somewhere else on the drawing sheet, the result is a removed section. Because the removed section is easier to understand when positioned to appear in its normal place on the view, it cannot be rotated in just any direction. See figure 8.15 for correct and incorrect ways to position removed sections. Use bold letters to identify the removed section and its corresponding cutting plane on a regular view. A removed section can be a slice section, the same as a revolved section, or it can show additional detail visible beyond the cutting plane. You can draw it at the same scale as a regular view or a larger scale to show greater detail. When a cutting plane passes through an object at an angle, see figure 8.16a, the resulting sectional view is called an auxiliary section, and it is drawn like any other auxiliary view. Auxiliary views will be discussed later on. On typical working drawings, only the auxiliary section is known as shown on the cut surface. However, if needed, other background features or parts beyond the auxiliary cutting plane may be shown. In Figure 816b, notice that the auxiliary section contains hidden lines. It also contains 3 incomplete views. A phantom section, also called a hidden section, shows in both in wait. A phantom section, also called a hidden section, shows in one view both the inside and the outside of the object that is not symmetrical. Figure 817. Figure 817 shows an object with a circular boss on one side. Because the object is not symmetrical, the inside cannot be shown with a half section, so the phantom section is not used. Sometimes drafters make exceptions to the general section rules, and these exceptions have become standard practice. For example, although showing hidden lines in a section view is undesirable, it is allowed in special cases to improve accuracy and clarity. Ribs and webs are thin, flat parts of an object that are used to brace or strengthen another part of an object. Ribs and webs are thin, flat parts of an object that are used to brace or strengthen another part of the object. Often, a true section of the object that contains ribs or a web structure does not appear to describe the part. For example, the section in Figure 818a would give the idea of a very heavy, solid piece, which does not truly describe it. Therefore, when a cutting plane passes through a rib or a web parallel to the flat side, section lining is not drawn for that part. See Figure 18b. Think of a plane passing through in front of the rib. If a cutting plane passes through a rib, a web, or any other thin, flat part at right angles to the flat side, draw section lines for that part. Figure 819 shows an example. Do not draw lines on sectional views unless they are needed for dimensioning or for clearly describing the shape. In Figure 820a, a hub is described clearly using no lines, hidden lines. Compare it to the incorrectly drawn section in Figure 1820b. On sectional assembly drawings or sectional views of how parts fit together, hidden lines are generally omitted. This keeps the drawing from becoming cluttered and difficult to read. See Figure 821. Sometimes a good way to avoid using hidden lines is to draw a half section or a partial section. In a sectional view, you should normally include all lines that would be visible on or beyond the plane of the section. In Figure 822, for example, the section drawing in Part A correctly includes the numbered lines, which match the lines on the drawing in Part B. A drawing without the lines, as shown in Part C, would have little value. Alternate section lining is a pattern made by leaving out every other section line. It can be used to show a rib or another flat part in a sectional view when that part otherwise would not show clearly. In Figure 823a, an eccentric piece is drawn in section. An eccentric piece is one that has two or more circular shapes that do not use the same center lines. A rib is visible in the top view, but in the sectional view it is not shown by section lining. The omission of section lining is standard practice with a flat part such as a rib. There is no visible lines to represent the rib either, because its top and bottom are both even with the surface they join. In fact, without the top view, you might not know that the rib was there. A drawing of an eccentric piece with a rib would look exactly the same. This problem is solved in Figure 823b, where alternate section lining is used with hidden lines to show the extent of the rib. Do not draw section lines on spokes and gear teeth when the cutting plane passes through them. Leave them as shown in Figure 824. In addition, do not draw section lines on shafts, bolts, pins, rivets, or similar items when the cutting plane passes through them lengthwise. through the axis, as in figure 825. These objects are not sectioned because they have no inside details. Also, sectioning might give the wrong idea of the part. However, when such parts are cut across the axis, they should be sectioned. The sectional assembly in figure 827 shows names and drawings of other items that should not be sectioned. A section or an elevation, side, front, or rear view of a symmetrical piece can sometimes be difficult to read if drawn in true projection. See figure 828A for the true projections of a symmetrical piece with ribs and lugs. Notice that the true shapes of the ribs and lugs are not shown. When drawing such a view, follow the example of figure 828B. In this drawing, the ribs and lugs have been rotated on a vertical axis until they appear as mirror images of each other on either side of the center line. Their true shape is not shown. Note that only the parts that extend completely around the vertical axis are shown with section lining. See figure 829 for another example in which the lugs are rotated to show true shape. Note that they are not drawn with section lines. When the section passes through spokes, do not draw section lines on the spokes. Leave them as shown in figure 830A. Complete this drawing with the section drawing for the web in figure 830B. It is the section lining that shows that the web is solid rather than made with spokes. When drawing a section or an elevation of a part with holes arranged in a circle, follow the preferred example in figure 831. In this example, the holes have been rotated for the section drawing until two of them lie squarely on the cutting plane. These views then show the true distance of the holes from the center, whereas a true projection would not. This is often called an aligned section. Rotating features in drawings is very useful when you want to show true conditions or distances that would not show in a true projection. Moreover, for some objects, only part of the view should be rotated, as shown by the bent lever in figure 832. Conventional breaks and symbols are used to show that a uniform part of a very long object can be cut out of the drawing. This makes some details easier to draw and easier to understand. See figure 833 for examples of long, evenly shaped objects whose parts have been broken out in the drawing. Using a break lets you draw a view in a larger scale, because the break shows how the part looks in cross-section. An end view usually need not be drawn. Give the length by a dimension. Board drafters usually draw the symbols for conventional breaks freehand. However, on larger drawings, they often draw conventional breaks with instruments that give a neat appearance. In CAD, polylines are used for breaks. See figure 834 for breaks drawn for cylinders and pipes. In this discussion, an intersection is a point where two parts join figure 835. Draw a true projection of the intersection. Drawing a true projection of an intersection is difficult and time-consuming. Also, such accuracy of detail is of little or no use to a print reader. Therefore, approximated or conventional sections are usually drawn as shown in figure 836.